back, my friends, and now we'll continue our lesson on numbers and where they belong in terms of being real, rational, irrational, integers, and not. And right now we're working on problem M. M as in Mary. And my first piece of advice for anyone dealing with logarithm questions is if you have a number like 8, you can re-express it as some base and some exponent. So even if you're not sure if it will help, you should do it anyway, because it's going to help. You just have to believe that when you have a number like 8 or 27 or 125 or 64 or things like that, you just express it as a base and an exponent, because it's going to help, gosh darn it. Because especially with logarithm questions. So we've done the first part. We expressed 8 as 2 cubed. As you can see right here, 8 became 2 cubed. I ran out of space there, so I will continue my discussion here down here below. So I'll just go ahead and rewrite what we have. So this is log base 4 1 over square root of 2 cubed. All right, now what about the square root business? Well, do you remember from back in the day, for example, that 49 to the 1/2 power, do you know what fractional exponents do? A fractional exponent is just a root. So that means that 49 to the 1/2 power is actually the square root of 49. And not only that, it gets better if you have like cube roots. So if you have 64 to the 1/3, for example, that equals the cube root of 64. So the denominator of the exponent indicates the root. That's what I'm saying. So I don't know if you know this, but there's a hidden 2 here. Did you know that? There's a hidden 2. If you look at the board, on my online viewers can't see it, but well, you guys can't see it either because I'm not seeing it. Oh, there it is. The 8 there. You see how it says root 8 is root 8 with the 2 on top? So square root really has a hidden 2. So that's and that's important because the denominator of the square root is then a 2. So in this case, for this one down here, this square root here is actually gives us a denominator in the exponent. So we can rewrite this. I'll go down a little bit further. I suppose I'll change colors. So we can rewrite this as log base 4 1 over, then now the denominator is 2 because it's square root. So this is 2 to the 3/2. That's right. 3 over 2. Log base 4 1 over 2 to the 3/2. Now, what about this 1 over business? Well, we talked about that too. And whenever you have 1 over something, you can just write that as -1. So this is really log base 4 of 2 to the -3/2 power. Wow. Lovely. Lovely. Okay. All right. Okay. Now, this right here, remember that exponents of the arguments in logarithms can be put as a coefficient. So what I'm saying is that this right here can actually go in front of the logarithm. And that will make things nice because that then gives us -3/2 times the log of 2 base 4. Now, what do we do to 4 to get 2? Whoops, that's supposed to be log. It's, yeah. There we go. And so now I'd like to focus in on this part right here. How do we solve this right here? Log of 2 base 4. Well, 4 to what power is 2? Isn't it the square root of 4 that makes 2? So what I mean is, like, if if you have, let's put this over here to show it's separate. If you have log of 2 base 4 equals some number, and you rewrite that in exponent form, this means that 4 to the x equals 2. And if you want, you could say this is 2 squared to the x equals 2. And if you want to rewrite that, you could say 2 to the 2x equals 2. Well, 2 is just 2 to the 1, so therefore 2x equals 1. And therefore divide both sides by 2. And you get, oh my gosh, x is a half. But you didn't need all those steps to know that log of 2 base 4 is a half. Because you should know that the square root of 4 is 2. And so 4 to what exponent gives you 2? 4 to what exponent gives you 2? 4 to the exponent of a half. Because the exponent of a half is a square root. So 4, how do I get from 4 to 2? I take an exponent of 1/2. Because that's what square root is. And so this means that this equals negative 3 over 2 times a half. Which means the whole thing equals negative 3/4. Which is, yes, what is it? Which ring does it go in? This is a rational number. So, and this one was m as in Mary. So that means that m goes here. A lot of steps for that. And it just keeps getting better too. Okay, let's go move on to P. Is everyone bored yet? Because I'm not. I'm loving it. This is getting better and better and better. You're what? McDonald's?
Oh, now it's copyrighted.
Oh, saying brand names makes it copyrighted?
What if we start singing songs? And you can't sing songs.
I can't sing songs.
No, copyright.
Now I'm really tempted to. Turn it, guys. Okay. This one right here is negative 2. So the cube root of negative 8. Now, I know you're all wary of square roots of negative numbers because rightly so, you're not allowed to have square roots of negative numbers because those will create unreal or imaginary numbers. But the same is not true for cubes. So if you take like negative 5 cube and then you cube it, negative 5 times negative 5 times negative 5. Hey, that's actually a negative number. That's negative 125. So cubes are not afraid of negatives at all. There is no restriction on the cubic functions in terms of their input and output. And so just because it's a negative inside the root doesn't make it unreal in any way. In fact, so the cube root of 8 is 2, and the cube root of negative 8 is negative 2. It's that simple. So this is, in fact, you can say it. Negative 2 is it's rational. What else? Integer is an integer. So that means that P goes in this right here. And don't put it in the rationals because although it is rational, it's also an integer. And you need to put it in the innermost circle in which it fits, the innermost ring. And now Q. Cosines and square roots. I love it. Alrighty. Q. Yes. Well, root 8 divided by root 16. You know you can divide numerator and denominator, and this just becomes 1 over the square root of 2 for that. And then cosine of pi over 4, that's root 2 over 2. We talked about that earlier, how the cosine of pi over 4 is root 2 over 2. So I don't know if you know this, but root 2 over 2 is really just 1 over root 2. Because if you divide numerator and denominator by root 2, you get 1 over root 2. So this is really 1 over root 2 minus 1 over root 2. And that, of course, is 1 over root 2 minus 1 over root 2?
Well, that's like,
Yes?
what is that?
It's 0. Thank you. It is 0. And where does 0 go?
That goes into the oh wait, no. Natural.
No integer.
So someone said real and then natural. It is not. It is real, but it's more than that. It is rational, but it's more than that. It is an integer. It is not natural because natural means 1 and greater for the counting the whole numbers. So 0 goes right here, which is R. Oh, not R. I'm sorry. That's Q. My bad. Wrong letter. Q. We're moving right along. We still have time. Now we're going to go to S. S looks like fun. That looks too easy. But it's fine. So, what about that base, huh? That base is a square root. Ugh. I have a way that I like to resolve this. I'm gonna copy this problem down to wherever. You know what? Let me just make some. Let's put it up here. That's fine. So the problem says log base root 2, log of 16 base root 2. And so what I'm saying is this equals some number x. And that's what we're supposed to figure out. We're supposed to figure out what that x is. And so what this really means is that root 2 to the x equals 16. I hope you all agree. And let's start re-expressing numbers with their with bases and exponents, because that's how we're gonna make progress here. Root 2, remember, that's just 2 to the half. So this is 2 to the half to the power of x. Whoever just opened that, I smell it. And that equals 2 to the 4th. Wow. If that's so, then that means that this is 2 to the x over 2, or half times x, or x over 2, whichever you prefer, equals 2 to the 4. And that, in turn, means that x over... Now we're just going to look at the exponents because the bases are the same. So we can now safely ignore the bases and just deal with the exponents. Multiply both sides by 2. X equals 8. So this is, in fact, 8. Let me use a different color. Which means that S is a natural number. Which means it goes in here. Hooray. Last one. 1 over e minus e. Well, isn't that irrational? Let's see. Let's find out. It looks like it's irrational. 1 over e minus e. Let's see if there's anything we can simplify. 1 over e minus e. I mean, we could multiply the other one by e over e. It would just be 1 minus e squared over e. And if you will, if you want, you could separate it out into 1 plus e times 1 minus e. I don't really see what good that would do, except that we know that we have an irrational top and bottom. 1 over e minus e. 1 over e is like, it's like 0.3 something something something. Minus 2. Yeah, that's going to be an irrational number. So this is a real. So t goes here. Alrighty, so that concludes our little lesson here on these very difficult numbers and where they go. Please like, share, and subscribe. Buy my merch if I have any, which I probably don't. maybe eventually. Help this go viral for no good reason. Even though I don't see the point, but thank you. This would be, if it goes viral, it would really be for no good reason. It would be merely because people made a joke out of it. Funding for my tennis team. All the money that I earn from this goes towards the tennis team at Hanford West. And a field trip for MRWC.